How can you simplify complex mixed air calculations for psychrometrics? Imagine trying to mix two different types of air and figuring out what the final air will feel like. It can seem complicated, but there are simple ways to make it easier. When you mix air streams, think of it as an adiabatic process. That means no heat is lost or gained from outside, and no work is done during mixing. This makes calculations much simpler because you only need to focus on the properties of the air streams themselves. Start with basic mass and energy balances. The total mass flow of the mixed air equals the sum of the individual air streams' mass flows. For example, if one stream has a mass flow of 10 kilograms per second and another has 5, the total is 15 kilograms per second. Enthalpy, which is the energy content of the air, can be calculated as a weighted average. You multiply each stream's enthalpy by its mass flow, add them together, and then divide by the total mass flow. This way, you get the mixed air's enthalpy without complicated calculations. Using psychrometric charts is another smart move. These charts show air properties like temperature, humidity, and enthalpy. When mixing to air streams, the final condition will be somewhere on a straight line connecting the two initial points on the chart. The position depends on how much of each airstream is mixed. This visual method helps you estimate the mixed air properties quickly and accurately. Digital tools like calculators or spreadsheets can also do the math for you, saving time and reducing errors. Focus on the dry bulb temperature and humidity ratio. These are the main properties that change when mixing air. To simplify, calculate their averages based on the flow rates of each stream. If you know the volume or mass flow of each airstream, you can find the weighted average easily. For most HVAC applications, volume-based calculations are enough, but for more precise work, use mass flow rates. When mixing more than two streams, you can extend the same idea. Use a weighted average formula. Multiply each temperature or humidity ratio by its flow rate, add them all up, and divide by the total flow. This approach works for temperature, humidity, and enthalpy, making the process straightforward. In practical HVAC systems, simplifying these calculations helps in designing better ventilation and energy recovery systems. It allows you to determine how much outdoor air to bring in, predict heating or cooling needs, and troubleshoot issues more efficiently. By sticking to these basic principles, mass and energy conservation, using psychrometric charts, and applying weighted averages, you can handle complex mixed air calculations with confidence. This method keeps things simple, accurate, and easy to apply in real-world situations.